Welcome to the first experiment. In this experiment, we will be modeling and simulating an RLC circuit using MATLAB Simulink and analyzing the voltage and current waveforms. We'll also be computing the RMS value, instantaneous power, active power, reactive power, and apparent power and power factor. So the procedure is mentioned here. So the objective is to create an RLC circuit like this. So we can get started. Click on MATLAB. And go to Simulink. Click on Simulink. You can create a blank model. So the objective is to create this RLC circuit. So you need a voltage source, an AC voltage source, resistor, inductor, and capacitor. So you can, to find out the components, you can go to the library browser and find out the component, or you can click anywhere here and search for voltage source, AC voltage source. So the value of the AC voltage source is given in the manual as peak value is given as 20. Sorry, RMS value is given as 20. So the peak value is 20 root 2. The frequency of signal is voltage is 50 hertz. Similarly, you can search for series RLC branch. Series RLC branch. If you need to rotate the component, you can click on the component and press Ctrl R. Double click here and you can change it to resistor. RL circuit, RL branch, and then RC branch. The value of resistor is given as 100 ohm. The value of the RL branch is 20 ohm and 30 millihenry. The RC branch is 10 ohm and 35 microfarad. And you can connect the components. So before running, you can save this file. You can click on save. You can give a name and click save. So you need to measure the voltage across the source and the current through all these branches, as well as the current, total current. So in order to measure the current, you need a current measurement block. So click anywhere and search for current measurement. So we have to keep this in series. Similarly, if you need to measure the current for each branch, you have to keep the current measurement for each branch. I'll be keeping one more here. So in order to measure the voltage, you need a voltage measurement block. So we have to take the signals and give it a, I'm giving it this a name. So I'm using a go to block. Giving it as I. Similarly for the voltage, given as V. So for this current, this is a branch 2 current. So in order to view this voltage and currents, you can take this voltages and current signals and give it to a scope. So before running the simulation, we have to go to modeling. As per the manual, we have to set the solver type as fixed step and step size as 1 microsecond. Go to modeling, model settings, change the click in the solver section, change the type as fixed step, and the step size is 1e-6. Also for running the simulation, you will require a power GUI block. So if we need to find out the active power of the circuit, so we have to first multiply the instantaneous voltage as well as current and find out the average value. So in order to do that, we have to take the voltage and current information and multiply it. So for multiplying, you have to use a product block. After multiplying, you have to take the average of the instantaneous power. So then only we will get the real power, the active power. So for finding the average, we can use a mean block, mean, in the specialized power systems. So when you're taking the mean, ensure that you give the fundamental frequency as 50, and you can display. Use a display block to view the value. So if we run the simulation, go to simulation and set the stop time as, you need not run this for 10 seconds, we can run it for say 0.1 seconds. Click on run. We can see the power, real power has come out to be 20.84. So if you want to find out the phase difference between the voltage and current through this branch, so you need to plot the voltage as well as current through this branch. So the voltage across this branch, all these branches are the same, so I am taking the voltage signal and the current signal through this branch. You can go to a scope, use a scope and double click on the scope, go to settings, select number of ports as 2. In the layout section, I am using this kind of layout so that 2 signals will be shown separately. So you can connect the voltage and the current to the branch. So run the simulation again. You can see, you can go to the measurement block here. In the voltage measurement, you can approximately, you can see, set the value at the peak value here. Similarly in the current measurement, keep the value at the peak of the current. So you can see the current is lagging the voltage. The peak of the current is occurring after the peak of the voltage. So you can say the current is lagging the voltage. And the time, corresponding time, you can note down approximately 1.4 to 3 millisecond. You can convert this into degrees. So 20 milliseconds will be corresponding to 360 degree. So this many millisecond will be corresponding to that much phase angle difference. Or in order to find out the power factor, so this is one way of finding the angle difference and finding out the power factor. Or we can find the apparent power first. So we have the real power here and we can find the apparent power. So apparent power is Vrms into Irms. So you can take the voltage and current in current signal again and use an RMS block. So you can select the RMS block from the specialized power systems. So I have connected the RMS blocks. So inside the RMS block, there is a fundamental frequency. I have to give it as 50 Hz. So we have the Vrms as well as Irms. So if you want to plot it, you can give it to a scope or a display. If you want to just see the value, you can give it to a display. If you want to plot it, you can use a scope. So here I want to take the product of Vrms into Irms. So I'll be using the product block, and I need the value to be displayed. So if I run the simulation, so the apparent power is coming to be 21.11. So if you need to find the power factor, you can take the real power by apparent power, that will be giving the power factor. So to find out the power factor angle, you can take the cos inverse of the power factor. So we have done phase difference, RMS value, active power, and now you can fill in the table for each of the branch currents. You can find reactive power also from this. If you have the power factor, you can find out the reactive power also. That will be RMS IRMS into sin phi, where phi is the power factor angle. So that's all for this experiment. Thank you.